Hi, this is Mike Lopez, and in this video we're going to be looking at the linear form of partial fractions. Okay, let's see what we mean by the linear form. Quick example, 3x plus 5 sitting over x plus 4 times x minus 3. Okay, so we have linear factors here at the bottom. X plus 4 is linear, x minus 3 is linear, so that's what we mean by linear. I'm saying this is equivalent to a, which is some value that you need to determine, a over x plus 4 plus b over x minus 3. And then what we'd like to do is to determine a and b, but we notice all of these fractions in the way here, so how are we going to simplify this expression for further analysis? Well, what you notice is that if you take a copy of this thing here, in fact, let's give that thing a tag or a nickname. Let's call it star. Okay, so get a copy of star and put it there, and then a copy there, and then a copy there, which means I've multiplied both sides of this expression by that purple star. Okay, so how's that going to help us? Well, what you'll notice is that these denominators here on the right are contained within that, so what's probably going to happen is all the denominators will fall away after we've done this multiplication between the left and right hand sides. Okay, let's change to red and have a go at that. We've got 3x plus 5, which is what I had in the first place. Okay, that's going to multiply. Okay, let's keep it purple. X plus 4 times x minus 3. That's going to sit over what was there originally, which was x plus 4, x minus 3. And then we're going to have over on the right hand side, we've got an a there, and then got this purple stuff again, x plus 4, x minus 3. That's sitting over, well, what was there originally? It's an x plus 4. Okay, and what we've also got is plus b lots of that purple stuff. I'll do in a second. That was sitting over. Sorry, that's not correct. It's sitting over minus 3, wasn't it? Minus 3 there. And this b is multiplying the x plus 4, x minus 3. Okay. Let's take some green, shall we? Let's see if we can cancel things out. X plus 4 cancels with itself there. X minus 3 cancels with itself here. X plus 4 cancels with itself there. And x minus 3 cancels with itself there. And that then leaves us with 3x plus 5. Equivalent to a lots of x minus 3 plus b lots of x plus 4. Okay, so we seem to have found a one-line expression, which is the same as that thing up there, so obviously it looks a bit easier to handle in terms of trying to find out what a and b might be. In fact, it's so useful that we're going to give it a tag. Let's give this expression a tag just over, I'll leave a space, and call it 1, okay, or nickname it expression 1. Okay, let's get a bit more space to work with, see what we can do with this thing. I need to find a and b. One usual way to do to find constants and solutions to your maths problems is to think, okay, maybe I could let x equal naught. Is that going to be of any use to me? We've got 5 equals so many lots of a plus so many lots of b. So that's leaving 2 unknowns and just one expression, so that's no use at all. So then you think to yourself, okay, so x equals naught doesn't work. How about letting brackets, if I see any brackets, let them equal naught? And in this case, that will work for us. So what we're going to do is we're going to say, as a first step, we're going to let that first bracket, which is x minus 3, equal 0. Okay, so if x minus 3 equals 0, what's the value of x? Well, obviously, therefore, x equals 3. Therefore, we're going to substitute x equals 3 into expression 1. So you're going to have 3 lots of 3 plus 5 equals, well, this a lots of 3, x minus 3, that's 3 minus 3 in this case, because we're letting x equal 3, so 3 minus 3 is naught. Naught times a gives you naught, so we can leave a space there for 0. And then we've got b lots of x is 3 plus 4, so I'm just rewriting this expression 1 here. Okay. Okay, let's simplify what we have. 3 3s are 9 plus 5 equals 7b. Therefore, 14 equals 7b. Therefore, b is 14 over 7, of course. B equals 2. So put a ring around that one. Okay, so b equals 2 is quite handy. Right, we picked on that bracket, and that was quite useful to make that bracket 0 because we found out that b equals 2. So why don't we pick on this other bracket here, x plus 4. Okay. So next bullet, let's go back to red. I'm going to say let that other bracket equal 0. Therefore, what's the value of x then? If x plus 4 equals naught, x must have a value of minus 4. Okay, so x has a value of minus 4. So if you substitute that idea into expression 1 again, then you're going to have 3 lots of minus 4 plus 5 equals a lots of minus 4 minus 3. Okay, so I'm just doing this bit here, plus b lots of minus 4 plus 4, which is 0 times b, which gives you 0. So this line is complete. Okay, so 3 times minus 4 is minus 12 plus 5 equals minus 7 times a. Okay, minus 12 plus 5 is minus 7 equals minus 7a. Therefore, a equals minus 7 over minus 7. The 2 minuses cancel, the 2 sevens cancel, so something over itself is always 1. Therefore, a equals 1. Okay, let me ring that. So, our proposed answer, we change colour. So, proposed answer. Okay, let's put the question in first of all. So, I'm saying 3x plus 5 sitting over x plus 4 x minus 3. Okay, so that's our linear form. We know from the very first line we said it was going to be a over x plus 4, but we know what a is now. A is 1, so it's 1 over x plus 4 plus b, and we know b up here to be 2. Okay, 2 over x minus 3. What we're saying is that's the answer. What do you think? Let's do a check. Let's do a check on our proposed answer. 1 over x plus 4 plus 2 over x minus 3. Let's see if I can move that line over there, makes it look a bit better. Okay. This thing is going to be equal to, well, let's do a common denominator. What do we have? Okay, put the brackets in, make it a bit more clear. Common denominator of these two, normally the best thing to do is just multiply them together and say that's my common denominator. Okay, so x plus 4, x minus 3. Then you say this denominator goes into the common denominator, x minus 3 times. X minus 3 times 1, x minus 3 times 1. This denominator goes into the common denominator, x plus 4 times. And then we have x plus 4 times the original 2 that was sitting there. Okay, and if we then evaluate all of that, we have, we've got, we just change colour for you, so that x times the 1, that gives you x, and that minus 3 times the 1 gives you minus 3, and then we have that x times 2, so that gives you plus 2x. We've got that 4 times that 2 gives you 8, and that's all sitting over x plus 4 times x minus 3. Okay, let's tidy up at the top. And what we have is 3x. Okay, if we've looked at that x term, then we've added it to that 2x, and that gets it to 3x. And then we go for the minus 3, add 8, and that's going to give you plus 5 over x plus 4, x minus 3, which of course is the original question. Which of course means that our proposed answer is indeed correct. And there it was there, complete with a check. Okay, thanks for watching and see you in the next video.